get started. Today, I'll be going over CNF orchestration with NSO. You guys may have seen our presentation from last year, but this year we're building upon that. We added many new things like Vanilla Kubernetes support for AWS EKS, and also XRD. So my name again is Khanh.
Yeah, and I'm Ravi, and thank you for your time to go through this session. So I'll have some slides to show you first before we do the real demo. So this is the agenda for today. We start with the context of why we are doing this and what's the logic behind the design of the core function pack. And section 2, we will go through the features, like what is inside core function pack and what you actually need to use it. And then good part of this session, we will go through the demo. So you see the real product in action. And then we end up with discussions. Okay, so with context, we see three types of network functions in the market today. So customers have physical network functions, which are dedicated boxes doing dedicated functions. And then the concept of VNF came up, and the same network functions are now running as VMs inside platforms like OpenStack or VMware. And of late, we are also seeing the CNFs, especially with 5G. The concept of cloud native network functions are becoming very important. So customers are also looking at deploying their network as CNFs. But we don't think only one form will remain. We think all the three forms will coexist. And the automation and orchestration solution should address all the three. Like you may have a service which have some physical elements, some virtual elements, some containers, but all of them together must be provisioned and managed for the customer to get the right experience. So this is the foundation on which we have created this NSO solution. And this is how it looks like from a very, very high level view. So you have NSO there. And as you know, the NEDs are managing the physical network functions. So the NEDs will connect to the device using a protocol that the device supports, and it will provision that device. Secondly, when you want to do VNFs, there is an extra thing you need to do, like the network function does not exist when you want to provision. So you have to create the function first. So in Cisco, we have created the VNF manager called ESC, Elastic Services Controller. So NSO will use the NFVO function pack, which is a set of pre-built packages that run inside NSO. So NFVO function pack will send the request to ESC, and ESC will spin up the VM. And after the VM comes up, it gets added into NSO as a device, and then NSO treats the device just like a physical device. So for NSO to provision a VNF, all it needs is a NED for that VNF. So the extra thing we do here is to onboard that VNF using the VNF manager. The same concept now we are providing on the CNFO function pack. So there is a CNF manager which NSO will use to create the CNF in a Kubernetes platform. So that Kubernetes platform, like Khanh said, could be a private Kubernetes platform, or it could be a public Kubernetes platform. So NSO will send the request to CNFM asking for creation of the CNF. And when the CNF comes up, it's added as a device into NSO. And after that, the management of the device is just like a physical network function. So you can have one NSO installed with NFVO function pack and CNFO function pack, and then you can manage a physical, virtual, and a container network function. So you can create a service across all these three domains with one NSO with one service. And there are more use cases you can think of, like migrating. This morning, we were talking about migrating from Juniper to Cisco or Huawei to Juniper. Now you are talking about migration from physical to virtual, virtual to a container, container to physical. Because we are using nets to provision the service, it can be provisioned in any form of function. Okay. So that's the context. Now let's specifically get into CNFO, because today's session is only about CNFO. We have done sessions on NFVO before, but today, since it is CNFO, I'm not going to cover the other two domains. So this is how it looks like. As I mentioned before, there are two components, the CNFM and the CNFO. So the orchestrator and the manager. So the CNFM is a software that is part of the CNFO function pack. So you don't need to procure this separately. You don't need to install this as a third-party software. It is something that's part of CNFO itself. So inside CNFO, there are enough data, the Docker files, to build the image for CNFM. Once the image is built, you host it somewhere and you can deploy it in your Kubernetes cluster. And CNFM can run, as you see here, on different types of Kubernetes clusters. Like we have certified this on Red Hat Openshift. So that's one of the paid Kubernetes platforms. Or it can run in Amazon EKS, which is a public Kubernetes platform, or it could be open source vanilla Kubernetes. So it doesn't matter. The CNFM is a software that is tested to run in different types of Kubernetes. And once CNFM runs, it has a confd inside, confd element. So it exposes a netconf interface. So from CNFO, we are also providing a netconf ned for CNFM. So using the netconf ned, CNFO can connect to CNFM. And using that interface, you can create CNFs and you can manage the CNFs. Okay, so that's the logic behind the core function pack. So the core function pack contains CNFM creation files, CNFM ned, and some service packages which help you to create the CNF based services. Okay, we are going to cover that in the next few slides. So what is inside that service package? So this slide gives you that detail. As you can see here, the top box, the CNFO, runs inside NSO, and the bottom box CNFM runs inside Kubernetes. But both functionalities are given as part of the core function pack. So the first thing we do in NSO to create a CNF service is to define a CNFD. CNFD is a CNF descriptor, which basically points to a Helm chart. So the entire solution we are basing on Helm charts because it's the most common way of deploying network functions in Kubernetes. And Helm charts is also the way HC is recommending to use in the HC model. So the Helm chart is defined inside CNFD, like the repository, the chart name, chart version, the values. So all those parameters are included there. In addition to that, we are also adding some NSO specific data. For example, if that CNFD is onboarding a CNF, is it a managed or unmanaged CNF? So if you have an unmanaged CNF, all NSO will do is to onboard that CNF in Kubernetes and leaves it there. If it is a managed CNF, there are some extra things done, like that CNF is added as a device inside NSO, and the net for that is also attached to the device. So all these definitions of which net to use and is it a managed or unmanaged device, they are all part of the CNFD. So the CNFD is the blueprint with which you can instantiate CNFs in Kubernetes. Okay, so the first thing we do is to create a CNFD. And CNFD is a blueprint. It doesn't create anything in Kubernetes. You are simply defining what to do. The actual request to create the CNF is a CNF instance. So CNF instance is what we do repeatedly. Once the CNFD is created, the instance is pointing to the CNFD and making a request to create that CNF. And that becomes a nano service inside NSO. And then as part of the service calculation, so the same NSO logic that you use, like your fast map, everything gets applied to the CNF creation service. And at some point, the CNFM ned is triggered to send the payload to CNFM. So NSO sends the payload to CNFM, which receives the CNF instance request. And here it has got two parts. So there is a Helm client, and there's also a Kubernetes client. So for all these operations you see here, install, uninstall, list, test, show values, add repo, we are using the Helm client. And for all the operations you see on the other side, the pod watch, get entities, or basically monitoring, we are doing it through Kubernetes client. So the CNFM has both Kubernetes client and the Helm client, because Helm is much easier when you want to do installation lifecycle operations. But for ongoing monitoring, we are using the direct Kubernetes API. So both capabilities are inside CNFM. So when the creation request comes, CNFM takes the request, identifies the Helm chart to be deployed. So it will go and pull the Helm repository chart, and then it will deploy it in Kubernetes. And if it is a managed CNF, it will also create the device in NSO. So all the day one, day two configurations, you can apply it on top of that device. So the demo we are going to show will create that CNF and also do the day two configuration. So you can see whatever I explained in action in the demo. Then as the CNF keeps running, the Kubernetes client can be used to monitor. So you know changes happening to the CNF. Or if you want to do some operations, basically you want to monitor, you want to look at the exec or log files. You want to look at the logs of CNF. You want to execute some ad hoc commands. You can do it through the Kubernetes client. So that's pretty much how it works. Okay, so let me stop here and ask if there are any questions. If not, we will go to the demo. Yes. You can definitely use this because you are creating the objects that Kubernetes understands. So at the end of the day, what you get here is your pods and services and deployments. So it's not necessary for only one source to create it. If you want that CNF to be managed by NSO as part of a network service, definitely you can do that. Because when you create this, you can also create another part of the service in your VNF domain or in a physical world. So you have all those options with NSO.
Hmm. We don't
Yeah,
have official support for Tanzu yet, but
yeah,
it was in our kind of like pipeline to do in the future.
yeah. So we have tested first with Red Hat OpenShift, then with EKS, and then with open source Kubernetes. Yeah. But there is nothing special to any of these platforms because it's a Helm chart we are deploying, and it's a standard Helm. Yes.
Hmm.
Yeah. But with NSO, the benefit you have is you can do your management of that CNF through the nets. So that could be a decision point. Like if you want to just create the CNF, you can pretty much do that in Tanzu. But if you want to do some customer configurations on top, this can give a better option. Yeah. Okay.
Okay.
Yeah. So this is one additional feature we have built into the core function pack, and this can be a very interesting use case also. Like there are some network functions which do not run as CNF. Maybe the vendor does not support the CNF part, or it is more optimal to run it as a VNF. So imagine a scenario where you are running a business where 90% of your services run as CNF and 10% run as VNF. Do you want to invest in a dedicated VNF platform just to run those small number of VNFs? Because that needs a big investment again. So this KubeVirt is a project of CNCF, and they are trying to create VMs inside Kubernetes. So you don't need a VM platform. You can as well run the VM inside Kubernetes itself. So we are supporting this because ultimately this also runs as a Helm chart. It's just that the objects that you are creating are not the normal uh, container objects. You are creating custom resources, but they can be packaged as a Helm chart and they can be deployed using the same CNFO and CNFM. So if you think of a use case where you have a lot of containers and a few VMs, you can pretty much look at KubeVirt as an option. And we do support it today in our solution.
Okay. Moving forward.
Yeah.
So this is going to be the first scenario for our demonstration. First, we're going to go over the XRD Helm chart in both what it looks like as a Helm chart and what it looks as a CNFD on CNFO. Okay. And next, we're going to onboard an XRD in Kubernetes using CNFO. like Ravi mentioned, we're using CNFO to push down a CFM NED, which then communicates to CNFM and then deploys this CNF here, which is going to be an XRD. XRD is the containerized version of XR. I think a lot of people use XR for maybe as a VM, XRv9K and such, but XRD is still something relatively new. And then we're going to onboard it with the XR NED. And once this configuration is done, we're going to push the day one configuration directly to the XR itself. Okay, let me go to my screen. So this, of course, is NSO UI. You can ignore this bottom part for now. But the top part is my CNFM. I've already onboarded it with the CNFM NED right here. And you can also see on my next screen, whoops. This is my Kubernetes dashboard. Here, CNFM right here is running as a pod. You can see here has a bunch of other objects as well. So let's go right back to NSO and look at the CNFD. So it is over here. See, this is the component for CNF. I have some other CNFDs here. So these are my list of CNFDs. I have one for Nginx, which is like a web server, one for EKS stuff, and one for XRD here. I want to click this one. And then I'm going to go see it in XML format. So this is the XML format of what a CNFD looks like. It has this object here. The name, of course, is XRD control plane. It's pointing to a Helm chart, also called XRD control plane. But there's something called key value pairs here, okay? If you guys know what a Helm chart is, it's a bunch of different values. So to better illustrate that, I have this. So right here is the actual Helm chart, and this is the values file. And in these values files, you could push different configurations to your specified container. Like, what do you do when you deploy like a virtual machine? There's an image, there's resources, that's basically the important stuff. But for a Helm chart, there's a bunch of different important factors. You can see here, like a lot of stuff is commented out on purpose. So we're actually going to configure that in the CNFD. So let me see. For image, I have something called an image repository, where I save the actual image. So it's on container Cisco. I have a pull policy. I have everything I need to deploy this XRD. Also included in this, where did my mouse go, is a day zero. Day zero is really important for deploying routers and such, but mine is a very basic one. I'm just going to deploy XR with this hostname XRD CP and some allocations for SSH and such. Also included in this, like I mentioned, is other networking configuration. I plan on adding another like subnet, another network using something called network attachment definitions. So this will allow another connection to my XR. So there's something called Multis, which is a CNI. This is how I'm using it to create this network attachment. And there's also something for management. So see here, manager interface. I'm allowing for manager interfaces to be configurable and one to be taken from the Kubernetes cluster. So I'm not going to go too deep into every aspect of the CNFD, but that's basically what it looks like. Next is creating a service. So as I already mentioned, the CNFD actually doesn't create anything on the Kubernetes. We're actually going to create the service by using CNF instance. So here, just do a little plus sign. I'm going to specify a name. So this is going to be the name of my service. I'm going to specify a cluster. So this cluster is where we define what kind of connectivity we want. So on my setup, it's a Kubernetes cluster. But let's say you have an Openshift cluster or you have a Tanzo cluster. You'll be able to change this configuration here to specify what kind of cluster you want to deploy on. And of course, we have to specify the CNFD. So this is the XRD control plane, device, specify the CNFM, and the chart version. So here, before I deploy it, this is just basically what it looks like. I need to go over here. Ravi mentioned there's stuff for onboarding and such. So I'm going to allow my CNF instance to be onboarded. Let's see. Edit config. You could go here and click onboard and just specify an off group. So off group, you know, is just a username and password. I'm giving it this username and password to be added on. Great. Other parts of this chart can be edited, like you can add different values to the other values in the CFD. So let me quickly show you that. Let me go back to CFD real quick. Oops. So, oh, there you go. All these key value pairs are editable, so I could also edit these key values on the fly as well. So like if I want to change like something in day 0, I could quickly change that. And then if you see here, this is a commit manager. I could add different values here if I wanted to, whatever values I wanted to specify. So here, this is what I'm going to be committing. This configuration here is going directly to the CNFM device. So it's going to create a chart, a release, and it'll deploy all those key value pairs I wanted. But on CNFO, this is all I'm specifying. It's creating a CNF instance, creating this XRD demo on K cluster, using the CNFD, and using this off group. So let's go ahead and commit this. So the commit is going on. Okay, I think it should be done. If I go over here, my NSO is being very slow right now. Let's go to Kubernetes real quick and check if the pod is being created. It is not. Looks like my NSO is stuck. Restart NSO? Or restart the browser? Let's see. Yeah, go ahead. Okay. No, it didn't deploy. Commit. In which cases, like. Mm-hmm. Yeah, so we're just starting to deploy different types of CNFs. So different CNFs do different things. Like XR is mostly like for L3 service or creating different services. We're more in the business of creating an infrastructure for you, allowing users to easily create XRD, which is actually relatively hard to deploy. We could deploy any other types of CNFs. Right now, the number of CNFs are very limited, to be honest, but they're continuing to grow at the moment.
Yeah. So we don't have any specific limitation of what you should do, but we are trying to create a platform using which you can onboard any CNF from any vendor. Very similar to what we did with NSO on the physical world. So if the net is there, use that to configure the CNF. So it could be an IT function, it could be a network function. And all we do is to take the Helm chart and deploy that and then manage it. Yeah.
Let me go back. Okay. Thank you for that, because now my NSO is loaded. So this is the plan. You can see here, this is the CNF plan. This is for my XRD demo. We also did a onboard, and we did init. Everything is in ready state. So one part I want to show you is part of the Helm chart. There's different objects, okay? There's something called stateful set, which is how deployment works, and there's also stuff for services and such. Part of the CNF plan will show whatever you specified in, or whatever is part of the Helm chart. Like there's a stateful set here, there's a component for pod, and there's a component for service, and one for the device for onboarding. So whatever is included in the Helm chart is going to be included here in the plan, so users could easily view whatever data they need. And then on the Kubernetes, we can see here, a new pod is created, XRD demo. We could log into it using this UI. So I told you the day 0, XRD CP is a host name. We can see here it has like a management interface and some SSH configuration. Great. So our XR is easily running. It's actually very quick to deploy, especially if you have the image loaded already. It takes 20 seconds mostly. So now that's done, we're going to add a day 1 configuration. So I'm going to grab one of my files. So here, I'm just going to add some basic day 1, some with some BGP config, adding a router, some neighbors. This is all just basic config that I'm going to be pushing. So I can just commit this to my XR. Hopefully my NSO doesn't hang again. Okay, I think it worked. So let's check the run config again, XR. So here you can see has a new router, has some BGP configuration. So we're able to onboard and also apply some day 1 config. It's very easy because we have a NED. So we got, this is just an example for one XR, but imagine if customers had hundreds or thousands, we could easily onboard and deploy. Yeah.
Yeah. So we are using the same XR net that you would otherwise use for physical device. The extra step is to onboard that CNF. And once it is done, NSO treats it just like a device. So there's no difference between physical or virtual device. Yeah. So you can also create a service across physical or virtual devices. Like here, it's just one XR device, but you may have to configure XR with some firewall which is running as a physical box. So you can stitch them together. The normal NSO process, you are now extending to CNFs.
Yeah, and I mentioned we have support for AWS. This is actually EKS, which is the Amazon version. So here, I'm just going to quickly look at the pods I have. I have a CNFM here. I already deployed XRD here. Of course, it's already onboarded as a device as well on my NSO. So I have XRD. I'm using something called a load balancer, a network load balancer to onboard this. I could quickly show that I could SSH to this guy too. So let me go over here. Hopefully this connectivity works. I use the same day 0. So over here, this is a different device. It has the same host name, but I could quickly just show that I'm able to deploy XRD on AWS and do whatever testing I want here as well. Okay, let's move back to the slides. So here, I think Ravi went high level of what the flow was. Of course, we create a CNF instance using CNFO, connects to deploys the CNFM. And then it actually goes down to the K8s cluster where we get a Helm request. And then here we get events. So there's different objects, which I talked about, right? There's stateful set, there's a pod. Those events come back to CNFM, and then we're able to get status ready, and then we're able to onboard and push a day 1 config. Pretty straightforward, but yeah. And the next part is KubeVirt. So Ravi highlighted what KubeVirt was. It's just a way for people who still use virtual machines and then want to use them, and don't want to fully onboard to Kubernetes yet. So example that I'll be doing throughout this demo is Catalyst. So Catalyst AK is Cisco iOS XE image. They don't have any release online for containerized images. So what we're using with KubeVirt is we're going to convert a KubeVirt, the image of XE to something KubeVirt will like. It's something we could deploy in Kubernetes. So I'll quickly go over what the Helm chart looks like, and then of course we'll use the same topology CNFO to CNFM to deploy the iOS XE. For timing purposes, we've already deployed that actually. So let me just quickly show what it looks like, the CNFD and such. So these are the CNFDs. Where is this? Oh, okay. So these are the CNFDs I had. This one is called Catalyst AKVM. I'll just show the XML. This Helm chart is very short. It's not because it's something I customized myself, not really something that's released on the web. But basically what this Helm chart is doing is there's something called volumes. And if you know what a volume is, it's just like an empty storage spot, right? So what KubeVirt makes us do is we convert the iOS.exe image into a volume. We extract all of the data to a volume. And what that allows us to do is just boot a container from it. So that's the solution that KubeVirt allows us to do. So this image here, persistence volume, is one we're just going to boot it up. It's similar as a VM. We're just going to allow resources, create some service, to allow connectivity. That's it. This is all we're going to do with this KubeVirt service. Again, this is a Catalyst AK. Service manager works the same. Let me show the plan. So, whoops. So again, we're going to the plan. So KubeVirt uses a different type of object. I went over some of these objects earlier. There's stateful sets, there's deployments, but KubeVirt uses something called virtual machine instance. We call it a VMI. This is a different type of object. I'll show you guys what it looks like on terminal. Unfortunately, on my cool Kubernetes dashboard, it doesn't support VMI, so I have to show everything on terminal in a second. And then it'll deploy a pod in a service. So the plan's all here. We could go back to my terminal here, and let's connect. Disconnected from my Kubernetes cluster, unfortunately. So this is a Kubernetes cluster. It has 3 nodes already. I have some pods, but the thing I want to show you is VMI. So this is my virtual machine instance. It is deployed on this guy. I can also do C8000. It's also connecting to that PVC I was talking about here. And so this thing is already running, so I could go to this console. So this is how you go to the console. It works just like a serial console if you guys like plug in some serial device. This image is even a serial device I used. So pretty cool. This runs just like a virtual machine. It runs same version, 7.10. Even thinks it's a VM. So if you look at here, this is like a virtual machine image. It uses Roman even. So yeah, this is basically the work we've done for KubeVirt and for XRD. You guys have any questions about any of this stuff? Sorry, what?
Recommendations for what?
For starting with Kubernetes and NSO,
Yeah.
it's like I'm new on that and it seems really interesting.
So starting NSO as a pod or like a container is something in the works. I think everyone's discussed.
No, you want to
Or he wants to get started with
learn
Kubernetes.
what to do with it, is it? Like,
Yeah, it's like first I would like to start like doing in my own lab,
Mm-hmm.
in my own lab and see what.
so the easiest way is you get a free Kubernetes instance like Minikube or something like that. Even Openshift has a free version called CRC. It's a single machine. You can run it in your laptop or Minikube, and then you get the core function pack, and it has installer for CNFM. Just install the CNFM inside the Kubernetes, and you can have a netconf connection into NSO. Then you get a free Helm chart like Nginx or MySQL or Grafana, something from, you have resources like Bitnami, Google Cloud. Get some charts and deploy and see how NSO processes it. And yeah, if you're happy with it, then try to create another service which has some NetSIM devices, some CNFs, try to connect them. Yeah. Hope that answers you.